Hello class, this is Mr. Coy. Please let me know if there is any audio troubles on this video. So first off, it's know Kirchoff's junction and loop rules, which we'll go over again. Apply Kirchoff's rules when solving circuits, and understand how Kirchoff's rules apply to parallel and series circuits. So your goal is to understand these by the end of today's video lesson. Alright, so Kirchoff's junction rule to start. The formal definition is for any junction, the sum of currents flowing into a junction is equal to the sum of currents flowing out of a junction. So, algebraically speaking, sigma I of n is equal to sigma I out. So, if you add, remember, this means sum all of the currents in, it will be equal to if you added all of the currents out. So, if we are talking about a circuit, what we mean is for any one junction. So we could say that this right here is a junction where our current is flowing in this direction and then it splits. So the junction rule says that if let's call each one of these sections a different number, color 2, and let's call this last one current 3. So the idea of that is if current 1 is flowing in, that's the only thing on the inside, so the current flowing in must be equal to all of the current that is flowing out. So that would be I2 plus I3. So a current, remember, acts a lot like a river. So the river, when there is two ways to go, the river splits up just like the current does. Remember, it can split up into multiple different directions, and we're again following the loop. So how many different paths are there? Alright, so next is Kirchoff's loop rule. And the loop rule states that the sum of all voltages around a loop equals 0. This is based on the conservation of energy, the idea that energy is neither created nor destroyed. So voltage can neither be created or destroyed, just transferred from another type. So to state this, we can talk about our initial voltage, so such as what your battery's voltage is, and then you would subtract for every voltage drop in your system, so that at the end it would ultimately equal 0. So for example, again, if we were to draw a circuit, we can have a resistor here, a resistor here, and 3 resistors in parallel. So, and again, I'm going to label these by color, so let's call this R1, R2, R3, and R4. So we originally start with a 9-volt battery, and then to write out Kirchoff's loop rule, we would have to subtract each voltage drop per resistor. So you'd have to subtract your voltage 1, so this is the voltage drop from resistor 1, voltage 2, which is your voltage drop from resistor 2, voltage 3, which is your voltage drop from resistor 3, and finally drop from voltage 4, which is the voltage drop from resistor 4, so that the total voltage is 0, except, remember, this is the loop of all of them. So if you're watching carefully, you'd realize this is sort of right, but not quite right. This only works if they are in a loop. So remember, they must be in a loop. So pause the video, try to correct this and figure out what went wrong, and then I will show you the correct version. Alright, so hopefully you thought about it. So first you got to think of each loop is separate. Remember, each loop gets its own total voltage. So we have a loop here in red that includes both R1 and R2. We have another loop here that includes R1 and R3. And we have a third loop that includes R1 and R4. So we actually have 3 loops, so we must write out 3 loop rules. You'll notice that R1 is in every single one, so there's going to be a voltage drop from every single one of those. Oops, I wrote R. Where that one equals 0. You will also have 9 volts minus, again, your voltage drop from 1, because that's still part of this, and then your voltage drop from R3, which will be 0. And last but not least, our orange one, still 9 volts, but you're subtracting V1, and you have to subtract our voltage drop from 4 to equal 0. So there are, for every loop, there is its own loop rule. So I'm going to give you a practice problem on the next page. Please attempt it on your own, and then you'll stay for the answer. Alright, so write Kirchhoffs loop and junction rule for the circuit below. So it's a 9-volt battery. We'll be mostly working with a 9-volt battery with 3 resistors. Alright, so please try to write the Kirchhoffs loop and junction rule. So first off, when you're doing, for example, let's start with the first one listed, the loop rule. You must first identify how many loops you have. There is one set of parallel, so we can see there's a loop here, and there is another loop here. So there, we know that we have to write 2 loop rules. So we have our original, this is our, we add 9 volts to the system, and then we subtract. Notice we only have 1 resistor over this, so we only have to subtract our voltage drop, I keep writing the resistor, from the voltage drop of the 1. We know that's equal to 0. And on the second one, we do have 2 resistors, so we subtract from the voltage from 1 and the voltage from 3 must equal 0. Alright, and then we look at how many junctions we have. There are 2 junctions. You see a junction here and a junction here. So we know that the current, and again, you should probably label these. We can have an I1 here, I2, and I3, and I4 here at the beginning, or end. So we can see for our first node that I1, so is the in, so remember it's the sum of current in is equal to the sum of the current out. So I1 is our total current in, so it must be equal to the 2 currents out, which is I2 plus I3. And then if we look at this node here, we can see that the in on this side is we have both I2 plus I3 coming in, and that the only one out is I4. Alright, hopefully this video was informative. About Kirchhoff's loop and junction rules. So and then we're almost done. Just a really quick on how does this apply to series and parallel. So in series, when we're talking about voltage, when you have resistors or bulbs in series, your voltage is overall shared. So this is based on the loop rule. They are on the same loop when they are on series, so they must subtract a little bit each from the 9 volt to eventually equal 0. In parallel, as long as there's nothing else going on there, in parallel, it gets the total voltage for the loop if they are only in parallel. I didn't realize I wrote voltage twice. Alright. Then when we're talking about current. So in series, The current, if it's only in series and there is no split, it will have, as according to our junction rule, the sum of. So it will have the sum of the currents. In parallel, it will have a portion of the total current. So when there's a split, it only gets a portion of the total current. Be ready on Monday for your daily quiz on how to write Kirchhoffs, junction, and loop rules for a circuit. See you on Monday.